Lesson 41 has two parts. The first part is on addition of like terms in rational expressions, and then the second part will be about some two-step problems. Now in the first part of this lesson we've been doing addition of like terms. These are just going to be dealing with some rational expressions. Remember, rational, that just means a fraction. So we'll be working with some fractions. Now if we had these two problems here, or these two terms, those are both like terms. They are like terms because on the right there we could move that x to the minus 2 to the top, and it would say ax squared over y as well. So just looking at them first glance, they don't look like terms. And these are the problems or types of problems you'll be dealing with now. You'll have these rational expressions, and at first glance they may not look like they have like terms in them. So you've got to do something to try to help you figure out better if they are like terms or not. And I think a good way to do it is just to make all of the exponents positive. I mean, there's a lot of things we could do. We could move all the variables to the numerator, all to the denominator, make all the exponents negative, or make all the exponents positive. So there's basically four things we could do there to figure out if they're really like terms or not. Let's just move all the exponents to the let's make all the exponents positive when we do these problems, and that will help us see if we have like terms. If we do, then we just add them together. Now look at this practice problem A. I want you to simplify that by adding like terms. Well, you might look at that at first and say, well, there aren't any like terms. But that's what I want you to do here is make sure of that by making all of the exponents positive, and that'll help us figure out if we really do have like terms or not. So we've got all the exponents positive in this first term. The second one, we need to move the x to the minus 2 up, so that'll make it x squared y. And then the third one, we have plus 7, and then move that x to the minus 1 up, so we'd have x squared, and then the y to the minus 1 moves up to make it a y. So we really do have three like terms there. Didn't look like it at first, but you see how that works. If we make all the exponents positive, that helps us more clearly visualize and see if we have like terms or not. So now we can just add them together by adding the coefficients. 3 and negative 1 is 2, plus 7 is 9, and so we end up with 9x squared y. So that's the simplification of that expression. Let's do another one. We have three terms there, and I want you to simplify this by adding the like terms together. So first what we want to do is make all the exponents positive. That's what we'll always do on these problems where we have ratios or fractions and then we have negative exponents. So let's make all the exponents positive, and so that first term on the left there, that will become 4, and we have a to the negative 5th in the denominator. We move it to the numerator, it becomes a positive 5. Minus 3 plus 5 is a squared. 4a squared b squared over x. Then we have plus 2a squared, and then b cubed over b would just be b squared over x. And we didn't have any negative exponents, but we just simplified the variables that were there. And then the last one, that'll be negative 5 a to the 6, and then we need to move that x to the negative 3 down and the b to the negative 2 up. So we'd have b squared over x cubed. So now let's go back and look at that. All of our exponents are positive now, and we can see clearly that the first two terms are like terms. They both have a squared, b squared over x in them. But the third term is not a like term. So we'll simplify by adding those two like terms together, and we'd have 6 a squared b squared over x minus 5 a to the 6 b squared over x cubed. And so that's our answer there. So anytime you're adding like terms or trying to add like terms together, whether they're rational expressions or not, the first thing you ought to do is get all of the exponents positive, and then you can more clearly see which expressions or which terms are actually like terms. Part B of this lesson deals with two-step problems, and if you look at this practice problem C, that's basically what we're talking about here. You'll be given an equation like this one, if x plus 5 equals 7, and then they'll ask you what is the value of some other expression. So like this one says, what is the value of x minus 3? If x plus 5 equals 7, what is the value of x minus 3? So how would you figure out the value of x minus 3? Well, think about it. The value, that means you want a numerical value instead of just something with variables in it. You've been given an equation, so you always know that you can solve an equation. So solve that equation, x plus 5 equals 7, for x. And then you can substitute x in to the x minus 3. So we subtract 5 from both sides and we get x equals 2. Now we know what 2 is, or what x is, it equals 2. We can figure out the value of x minus 3. That's our second step, basically. So 2 minus 3 is a negative 1. So there's our answer, negative 1. That's the value of x minus 3. So all you do in these two-step problems is apply the solution to one equation. You apply that to another statement. Let's do one more. If x minus 7 equals 11, what is the value of x plus 2? Well, we have an equation there, so we can solve that for x. Once we know what x is, then we can substitute it into x plus 2 to figure out what the value of that is. So add 7 to both sides here, and we'd end up with x equals 18. And so what is the value of x plus 2? Well, we would just say 18 plus 2. That's equal to 20. So x is equal to 18, therefore the value of x plus 2 would equal 20. So in these two-step problems, step 1 is solving for x, and then we apply what we learned from solving that equation to the second step, and we figure out the value of x plus or minus some other number. Okay, well that's all for lesson 41.